All right, in previous lessons, we've introduced logs and we've done operations with logs and graphed logs. Now we're going to look at properties of logs. Properties of logs work inversely as properties of exponents. So if we look at the three main properties of logs, if you have the log of two factors getting multiplied together, that's the same as two separate logs being added. So multiplication is linked by adding. Okay. Division is linked by subtracting. Raising what you're taking the log of to an exponent is linked by multiplication. Now that's a coefficient on the outside. It's just like the properties of exponents, just backwards, right? Like if you have like bases and you're multiplying with exponents, you add the exponents together, right? Multiplication and addition are linked that way. If you have like bases and you're dividing, you subtract the exponents, right? Division and subtraction are linked. If you raise an exponent to another exponent, you multiply the exponents together. So power and multiplication are linked in that way. All right, so what we're going to do is, in example 1, prove two of these. All right, basically just so you get an understanding of where these properties are coming from. And then we're going to apply them in future examples here. So the first example we're going to click through is proving the product property. All right, so we're going to let x equal let x equal log base b of m, and y is going to equal log base b of n. We're going to convert those to exponential equations, right? So base b raised to the power of x is equal to m. Base b raised to the power of y is equal to n, and that's what you're seeing there. So if I multiply b to the power of x and b to the power of y together, you get m times n, because they're both equal to m and n respectively. The property of exponents, when you have like bases and you're multiplying, you add the exponents together. So now it's x plus y is the exponent on the base b. M times n is mn. Convert this now to a logarithmic equation. All right, it's log base b of mn is equal to the exponent x plus y. Again, x is equal to log base b of m. Y is equal to log base b of n. So when they're separate, you're adding them. When they're together, you're multiplying them. I guess I could do that. All right. The you try it example is to go through the same process, just with the quotient property. So give it a try. Try to write it out the same way that the property of the multiplication property was displayed. So pause it, give it a try, and then come back and check your answer. So the quotient property of logs is, division on the inside is subtraction on the outside, right? So we're going to take log base b of m, set it equal to x, log base b of n, set it equal to y, convert those to exponential equations. So you have b to the power of x is equal to m, b to the power of y is equal to n. So if I divide b to the power of x and b to the power of y, that should equal m divided by n, right? When you have like bases and you're dividing, you subtract the exponents. So now the exponent on b is x minus y, and that's equal to m divided by n. Then I can write it as an exponential equation. I'm sorry, write it as that is exponential. Write it as a logarithmic equation. So the exponent x minus y is equal to log base b of m divided by n. And then I can convert x and y back to log base b of m and log base b of n. So again, you're showing subtraction on the outside is division on the inside. All right, let's look at example 2.